Good afternoon. We are starting our next unit with PO34. So we're starting off already with that power objective. Remember, before break, we did have quite a few days of retakes when we were working on those graphing pictures. So we should mostly be done with retakes from the last unit. So we should be starting off fresh. You know, if you still have some retakes left, I'll have to double check. Most of us are done with retakes. So we're starting off our next unit with, we're going to be working with proportions, but we're going into deeper stuff that we have not done before. So our first one is I can use direct proportions in real context. We are going to be working with word problems, not just having the math equation set up and being able to solve them. We're really truly thinking about how we can learn those word problems, how we can break them down. So I'm not entirely sure what we're working on with our calculator and writing stuff in, because we haven't learned anything yet. So we're not trying to work ahead. Let's just follow along and make sure that we are doing things correctly. Okay? So there are three types of proportions: direct, partitive, and inverse. The easiest one is the direct ones that we are doing today. These ones we're going to read the problem and go, oh, this makes sense. I get how to do this, okay? Because it ties in with what we have learned in the past. Then we're going to be getting into more challenging ones where we go, ooh, this is totally new and different. So when we start off units, we usually start off with something that we kind of know, just going a little bit deeper on it. So today's isn't going to be an overwhelming lesson getting into the math, but it will get more challenging as we go through, and we really do need to be in the habit of paying attention. Direct proportions and partitive proportions will seem familiar, while inverse proportions will likely be new. So let's see, what is a direct proportion? A direct proportion is the relation between quantities whose ratio is constant. So let's see what that means. This objective will require concepts from past lessons, including unit rates and proportions. Remember, if something is proportionate, you are multiplying by the same scale factor. Whatever you multiply the bottom by, you're multiplying the top by, right? We worked with those proportions in the last unit. We knew the 5 different ways to be able to prove that it's a proportion. So let's look at how we're going to break down these questions. It says, answer each question and show your work. Okay, how are you coming up with it? You're not just using a calculator. Gavin, we haven't started yet. You're not just using the calculator and putting an answer. We have to show our work. What math are you actually doing? So, a car travels 300 miles in 6 hours. How many miles can the car travel in 8 hours? So first, let's look at what that first ratio is. 300 miles in 6 hours. We want to know how many miles it can go in 8 hours. How can we go from 6 hours to 8 hours? What do you think we should do, Ellie?
Well, first I would figure out what 1 hour is, so I would divide them by 6.
Perfect. That using that unit rate. So the first thing we want to do is we want to say, well, what is our unit rate? And then we can multiply it up. So remember that unit rate, we want the 1 on the bottom for 1 hour. So we're dividing it by 6. What is 300 divided by 6? 50. So we can go 50 miles in 1 hour. Now I can go up to 8 hours. To go from 1 hour to 8 hours, I multiply by 8. Whatever I do to the bottom, I do to the top. So 50 times 8 is 400. So I know I can go 400 miles in 8 hours. So my answer to A is 400 miles. Then it says, how many feet does the car travel in 8 hours? So I know I can go 400 miles in 8 hours. How do I figure out feet? What do you think I need to do? Elliot? Yeah, those conversions. How many feet are in a mile? Who remembers how many feet are in a mile? Cameron?
5,280.
So what did you say, 5,280
Yes.
feet are in 1 mile? So if we have 400 miles, how can we convert that 400 miles into feet? Finley? Divide what?
400.
So if I have 400 miles, what am I going to divide it by? Think about that for a moment. What do you think we should do, Clara?
5,280 feet multiplied by 400 miles.
Oh, you went the wrong way. We need to multiply them because it's 5,280 feet in 1 mile and we have 400 miles. So we actually need to multiply those together. So how many feet would that 400 be? Oh, I'm going to need more space than that. Elliot?
2,112,000.
So that 400 miles is actually over 2 million feet that we can go in those 8 hours. So that's my answer for B, right? Because I multiplied those together. Now, it says how many miles is the car traveling per hour? Have we already found that answer? We needed that to solve the previous question. So I don't have to do that math again. I already have that answer. How many miles is it going in an hour? 100? 50. Then our last one. How many feet is the car traveling per second? Oh my. Using our knowledge, what do you think we need to do to solve that one? How many feet is the car traveling per second? What do you think, Joe?
They're traveling 50 miles in 1 hour, and they're 60 minutes in an hour, and 60 seconds a minute.
Okay, hold on. So 50 miles in 1 hour. We've already done that math. Tell me what you said again?
There's 60 minutes in 1 hour, so 60 seconds in each minute.
So I know it's 50 miles for 60 minutes. How do I break that 60 minutes down to seconds?
60 times 60,
So 60 times 60 is what?
1,200.
So you're going a kind of complicated way. Do we really want that many seconds if we want to know per second? I don't think we want to multiply up. I think we want to divide it down, right? Because we want to go down to 1 second. So 60 minutes would be easier to divide down to 1 minute. Okay, so let's divide this by the 60, so we go down to 1 minute. So what's 50 divided by 60? Did I do that right? Oh, we want feet. Ugh, that's where I'm getting confused. So we converted to minutes on the bottom, we need to convert to feet on the top. So 50 miles is how many feet? So we want to get to feet and then to seconds. So how many feet is 50 miles? If we know there's 5,280 feet. Joe?
264,000.
Say that again?
264,000.
264,000 feet would be in 60 minutes. Because we've got that same 60 minutes on the bottom. We just converted from miles to feet. Now let's go down to 1 minute. So instead of 60 minutes, now we want to go down to that 1 minute. So now we're going to divide it by 60. So 264,000 divided by 60, going down to the 1 minute, how many feet would that be? Ellen?
4,400.
4,400 feet. Now, we need to go down to seconds. Okay, so we've got 4,400 feet in how many seconds? 60 seconds, because 1 minute, we know we can convert to 60 seconds. How do we go down to 1 second, Ellie? Divide it by 60. So that'll bring us down to 1 second. What's 4,400 feet divided by 60? Finley? 73.33 feet. Does that make sense how we figured that out?
Yep.
So some of these are going to be easier. Some we go, oh, we already did that math with one of the other ones we were solving, or we just have to do a little. Some of them, it's a multi-step. Okay. Let's look at our next one. I need to scroll up. Now, a 40-ounce jug of grape juice costs $4.80. So I need to write what that ratio is. So 40 ounces is $4.80. Okay, I'm going to use that information to solve my questions. At this rate, how much would be 65 ounces of juice cost? What do you think I need to do?
I know how much it costs for 1 ounce.
I need to go to a unit rate of 1 ounce, right? So I'm going to flip it to put my ounces on bottom, right? Because we can say $4.80 for 40 ounces. I want to go down to 1 ounce. What do I have to do to go down to 1 ounce? Holland?
Divide by 40.
Divide by 40. What is $4.80 divided by 40? How much would 1 ounce be? Ellen?
12 cents.
12 cents. Now that I know how much 1 ounce is, can I find 65 ounces? Yeah, I just multiply it by 65, right? That scale factor of 65. So now we will have 65 ounces. What is 65 times 0.12? How much money will it be? Gavin?
$7.80.
$7.80. 65 times 12 cents is $7.80. So I would put that right there. Now, we find a different brand of grape juice that is 35-ounce jug for $3.85. Which jug of juice is the better price per ounce? Well, we know per ounce for our first one is 12 cents per ounce. So So we need to find out what that unit rate is for the 35-cent, or 35-ounce jug. So I know it's $3.85 for 35 ounces. What do I have to do? Clara?
Divide, wanna divide both by 35?
Yeah, because I want to go down to 1 ounce. What is $3.85 divided by 35? Finley?
11.
Yeah. That 11 cents. So it says, which jug of juice is the better price per ounce? So I know it's 12 cents for 1 ounce for our first jug, and it's 11 cents per ounce for our second jug. Which one is the better price? The second one, right? So I'm going to write the 35-ounce jug. That's the one that you would want to get because you get more for your money. Now C says you have $20 to spend and decide to purchase as many jugs as you can of the juice that's the cheaper price. So this 11-cent one. How many jugs can you buy with 20 ounces? And how much money will you have left over? So we are buying 35-ounce jugs for $3.85. We have $20. How many jugs of juice can we buy? What do I do? Think it through. How can we figure out how many jugs of juice to buy? I have $20. One jug is $3.85. What math should I do? What do you think, Emily?
You can multiply 385 by something that you think would get you close to 20, like 5.
Okay. So what would 385 times 5 be? Because I know 5 times 3 is 15. So I know that's going to get me close, then I have all of those cents. What is 385 times 5? Holland?
19.25.
Do you think I could buy another jug? No, because I only have $20 to spend, right? So Henry was doing some number sense, thinking, well, what number do we think I can multiply 3.85 by? That would get me close. You might say, well, 3 times 6 is 18. So that would get me maybe even closer. So you could guess and check with some of them if you're not sure. But Henry guessed good with that 5. Is that the first one that you used, or did you guess and check some other ones first?
That was the first one I used. I thought it was closest to 4, and 4 times 5 equals 20.
Ah. So he was just, you can guess and check on some of these. You could have done 20 divided by 3.85. What would you get if you did that? What's 20 divided by 3.85? Finley?
5.19.
Yeah, 5.19. Well, we can't get 0.19 of a jug. So that would tell me, ooh, let's go with the 5 whole, that whole number, and there's going to be some leftover money because I can't use that small amount. So you could either guess and check multiplying up, or you could divide backwards to see what number you get. So if I buy 5 jugs, that's the first part of my question. I have a second question. What's the second question I have to answer, Joe?
Kid will you have left?
How much money will you have left over? So how much money will we have left, Ellen?
75 cents.
75 cents. Because 20 minus 19.25, I have 75 cents left over. Does that make sense? Make sure you answer all questions. Sometimes we have 2 questions we have to answer. On the test, we know if we only answer one, we're going to get it wrong. Make sure you're answering all questions. If we look at our second page, this is our work page. Let's see what we have to do. It is more word problems. You set a goal for the summer of making $3,000. So read through your A, read through your B, and answer them. Then we have the math course objectives. And then we have, do you guys have the one apple weighs the same as 2 kiwis?
Yep.
And then at the very bottom, you have a time for review. So that's reviewing stuff from past units, okay? So go through just like on that first page, one question at a time, really thinking what math we have to do using those unit rates, using conversions, okay? Use that prior knowledge to help you answer your question. I will be over at my desk if you have questions on how to solve something, come up and check with me, okay? But I'm gonna give you time to work these out yourself. We were working off the first page together, giving us an idea of how to do it. Now you're gonna do it yourself. If you finish, what do you think you should do? Math packet number 6, okay? Make sure you're working on that. Double check, make sure you have packet number 6 and you didn't lose it over the last 2 weeks. You need to find it. None were left in my room. So you should have yours. Make sure you have it. Make sure your name's on it. If you are watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day.